In this lesson, we're going to look at linear inequalities. But before we start, we just need to review what an inequality is, how to read it, and more importantly, how to graph it. So we look at this one. What does this say? In English, we learn to read left to right. So we would read this as x is greater than 1. How do we graph that? Well, we want to put an open circle around 1 because it's not equal to it. And then we want to shade to the right because we want to look at all the numbers that are greater than 1. There's an infinite amount of them, so we can't list them all. Because yes, it includes all the decimals and the fractions. It's not just 1, 2, 3, 4, 5. Right? So that's why we have a picture representation. Let's look at this one. A little bit easier, maybe. X is less than or equal to -2. That little bar right there is half of an equal sign, so it can be equal to -2, and then that symbol is less than. So here we would put a filled in circle for the equal to part, and now less than, less is to the left. Less is to the left. Now math is not English, so sometimes we don't read left to right, we read right to left. So since you're saying what is x, it's best to start your sentence with what is x. In this case, x is less than -1. If you look at that arrow, the smaller part is pointing to x. X is less than -1. So again, you'd have an open circle because it's not equal to, and left is less. Left is less. Right? Let's look at this one. Again, we start with the word x. X is greater than or equal to 0. The bigger part is opening up toward x. X is bigger than, and then we have the bar, so that's the equal to part. So we're going to put a dot or filled in circle on 0. We want to do greater than, that's to the right. All the bigger numbers are to the right. Then let's look at this next example. X is sitting between two numbers, right? So you can read this a whole bunch of different ways. This really says x is greater than -2 and less than 3. Okay, greater than -2 and less than 3. Another way you could say is that x is between -2 and 3. So again, we don't have any of that equal to part, so I want open circles on both, and then x is between. I always think about an Oreo cookie, which I just love, and so x is the stuffing in the middle, and then your -2 and 3 are the cookies. Another thing we need to remember about inequalities, they're not quite the same as an equal sign, right? So if I have 2 is less than 9 right here, it says if I have A is less than B and C is positive, that's greater than 0. If I multiply by a positive number, that inequality stays the same. Meaning, if I take 3 times 2, that's going to be the same thing as not the same thing, but it's still going to be less than 3 times 9. 6 is less than 27. Meaning if I multiply by a positive number, the inequality doesn't change. However, if I multiply by a negative, we flip that. So if I multiply by -3, and I left my sign like I just did, I would be saying -6 is less than -27. And that is wrong. Alright, if you look at a number line, here's 0, here's -6, here's -27. -27 is not bigger than -6. It is less than -6. So we would have -6 is greater than -27. In other words, if you multiply or divide an inequality by a negative, you reverse that inequality or flip it around. Right? So multiplication or division by a negative number reverses that inequality. Other than that, you treat them just like equal signs. All right, so let's just go through some pretty easy steps. All right, we're going to solve the inequalities, and I'm going to ask you to graph it also on a number line. Nothing elaborate, just to show me that you can shade in the appropriate direction. All right, so on our previous lessons, we've solved for x. Same thing. I want to get x by itself. I have a minus 6, so I want to add 6 to both sides. I'm not multiplying or dividing, so I'm going to keep that inequality the same way, and I get that. Okay, so then I want you to put it on a number line, and all you have to give me is 5. You don't have to put all the others unless you want to. Okay, so I want an open circle because it's not equal to, and then greater than, I'm going to shade to the right. All right, and I know with my fancy computer that's pretty easy, but you could just take your pencil and do that. That's fine. All right, so now I have x minus 11, so I'm going to add 11 to both sides. So that's 9. Bring down the inequality just as it is. We did not multiply or divide by a negative. Now, number line, again 9, you need to read it from x. X is less than 9. So open circle on the 9, less is to the left. Less is to the left. Got to read it from x. Now number 3. Now we have x being multiplied by a number. Remember that last lesson on equations? How do we get rid of that? We would divide both sides by negative 3. And so I would have 1x and I would have a negative 8/3, but because I've divided by a negative, I'm going to reverse that inequality. So number line, negative 8/3, open circle because it's not equal. And now read that, x is less than negative 8/3. Now if you're not sure, let's test some numbers. Okay, so you have to kind of know that negative 8/3 is the same as negative 2 and 2/3. So you should know 0 is over here somewhere and negative 3 is over here somewhere. So if I put 0 in here and said, is negative 3 times 0 greater than 8? Is that true? Is 0 greater than 8? No. So that's why you would not have shaded on that side. That's why 0 would not be included. But if you put negative 3 in, is that true? Yes, it is. All right, so you can, if you're not positive of which way you can shade, you can pick a couple of test numbers and test them. All right, let's look at these next two examples. Getting a little more complicated, so treat it just like an equal sign. So the first thing we would do is, yes, we'd want to subtract 2, bring down that negative 3x, keep the inequality. Right? I subtracted 2. Only do you flip it if you multiply or divide by a negative. And here that comes. I'm going to divide both sides by negative 3. So that reverses, and I have the answer. X is less than negative 3. So I'm going to put that on a number line. Open circle, less is to the left. Let's look at number 5. So I want to get my x by itself, so I have 3x plus 2. So I want to subtract 2 from both sides. Now I need to get x by itself, so I'm going to divide by positive 3. So am I going to reverse that? No, I am not. I divided by a positive number. So this time we have 4. We have an equal to part, so I want to fill that in. Read it from x. X is greater than 4. And again, if you're not real sure, pick some numbers, 5, 6, and come back here and plug it in and see if you get a true statement. So if I plugged in 5, you can see that that would be true. But if you shaded over here, like for 3 or 2 or 1 or 0 and plugged it in, you would get a false statement. So just another good way to kind of check. All right, now we're getting a little bit more complicated, just like those equations. So let's review those steps. If you have parentheses or fractions, you want to get rid of those first. We want to collect like terms on each side and then isolate that x. So I'm going to collect like terms, collect like terms. Now you get to decide what side would you like your x's on. Well, I think I'm going to move mine to the left. So I have 6x minus 4 greater than or equal to 8. All right, moving my letters. Now I need to add 4 to both sides. So that same rule about drawing that vertical line down your paper through equal signs, same thing with inequality signs. Try to keep that all nice and straight. What's the last step? Dividing by positive 6. So I am not reversing my inequality. I want to put that on a number line. I want to fill that in because it's greater than or equal to 2. So greater than is bigger than 2. And again, you could check. Now it's not a for sure 100% check, but it's a pretty good check. You could fill in some numbers bigger than 2 up here for x. That's only if you want to. It does take a little bit of time. Again, if I'm going too fast, pause that video, rewind, listen again. All right, number 7, we have fractions. So we could either get rid of them or deal with them. Well, you know me, I'm going to get rid of them. So I'm going to look, what is my least common denominator between 2 and 4? It's not 2, you have to go, it can't be any smaller than the biggest number. Sure enough, it is 4. You could use 8, but 4 is better. All right, so just like on the last lesson, I think I'm going to spread this out just a little bit so I can have some room to multiply everything by my LCD. So I'm going to multiply that by 4, this times 4, and this times 4. So I have 1, 2, 3 things to multiply by 4. And why are we doing that? Yes, to get rid of our fractions. So 4 goes into 4 one time. So I have now 1 times 5x plus 5. 1 times 4 is 4. Here, 2 goes into 4 two times. So I'm going to keep the 2 and then keep my parentheses the exact same. Remember that? Now I'm going to distribute, and of course 1 times this parenthesis just is the parenthesis. But distributing the 2, I have that. Now I'm going to collect like terms, so I'm going to put that together. What side would you like your x's on? I think again I'd like them on the left, so I'm going to subtract 2x. I'm going to subtract 9. I might run out of room here. Let's see, 18 minus 9 is 9. And then what's my last step? I need to divide by 3. Right, so if I divide by 3, I am so sorry, I'm cramming this in. I have x is less than or equal to 3. I did not divide by a negative. I do not need to flip it. I still need to put that on a number line. So fill that in. Read that inequality. That's less than. X is less than or equal to 3. All right, you see on the last 3 examples we have sandwiches, okay, my Oreo cookie ones. X's are in the middle, but it has some other stuff. So you still want to get x by itself. So you look and say, well, what's happening to x? Here we're adding 1. What undoes that? You're right, subtracting 1. But this time I have to subtract it not from 2 places, but 3, all 3 parts. Okay, so that's going to be negative 7. Bring down that inequality. That's 0. 3 minus 1 is 2. X is by itself. You're done. Except for putting that on a number line. So we put the negative 7, we put the 2, they're open circles, and X is like the stuffing in the middle of that Oreo cookie. In the middle. That means all the numbers between 2 and negative 7, if you put it back into that inequality, is going to be a true statement. Pick a few. Try it out. Right, number 9. Here's our x, and we're subtracting 5. So I need to add 5. And again, you do it in all 3 places. just so happened I have the same looking number. Okay, one's negative and one's positive, and we all know that's not exactly the same. It's just coincidental that those worked out like that. Right, I'm just checking my work. Negative 9 plus 5 is negative 4. Negative 1 plus 5 is positive 4. Alright, so x is between negative 4 and positive 4. It had those equal to parts, so I fill that in, and x is sitting between there. So any of those numbers would make that a true statement. Okay, number 11. Just needed to erase that so you could see it. Alright, so look at what's here. What do we need to get x by itself? Well, we would need to add 3 first. Negative 11 plus 3, that's negative 8. That's 4x. That's 0. That's 6. Now we need to get the x by itself, so I'm going to divide everything by 4, and yes, I'm going to reduce. That reduces to a fraction of 3 over 2. Again, I want to put that on a number line between negative 2 and 3 halves. No equal to part. X is in between those numbers. That's called a compound inequality. You work it just like an equal sign. If it helps kind of cover up one part and say, well, if it didn't have that third part, what would I do? Just think about the only tricky part is when do you reverse that inequality.